Alrighty, can everybody hear me okay now? Awesome. So what I'm here to talk about is, animations for web and hybrid. Probably going to go for about 30 minutes, and we'll go because there's always a whole lot of questions when we talk about this type of stuff. Who am I don't really need to cover. We just went through that. I guess a bit of an update. I will sometimes work with, Vue and React and things like that as well now. But my preference is always Ember. I really enjoy working with that. If you're not really sure about Ember, come up and talk to me later, and I'll tell you why it's a good idea. Only two plugs to get started. One is, he mentioned, I'm a partner at a company called Isle of Code. We're based in Toronto and Houston, and we mostly focus on those front-end frameworks and actually building performant hybrid apps. That's basically what I spend all of my time on. And we actually maintain a bunch of open source projects internally. Render Vendor, if you're looking for a way to take a template and spit out a PDF, it's much more performant than like your WK HTML to PDF or whatever you're using. And Corber and Ember Cordova, which is the last little pitch I'm going to give you, and please do check this one out. I actually only took Corber live about 6 weeks ago. It's an extension of a 2-year-old project I was working on called Ember Cordova. And what that did, if you're an Ember developer, was it unified your Ember build pipeline and your Cordova build pipeline. So you could run a single build that would spit out a Cordova hybrid app for you. And added a whole bunch of supporting features to that, such as on-device live reload. So you could go and change your Ember app in development, have it running on an iPhone, running on an Android, and see that reload and correspond immediately. And added some helper functions as well, like automatically generating your splash, automatically generating your icons. The next feature we're releasing will actually automatically set up all of your Apple signing provisioning profiles for you as well. What Corber is me taking that project and making it work for any React developer, any Vue developer, or basically anything that runs on Webpack as well. So take a look at Corber.io. You can just run Corber init and Corber build from any existing project, and it will go and build a hybrid app out of your existing work for you. Not going to demo it just in the interest of time. So what are we actually going to cover today? A couple of things. One is just, what do we care about when we're thinking about animating? I'm going to go through, some examples. I'm going to show you how do we profile the performance of an animation to actually see what's going on. And then just, what other choices do we have? So I'm going to go into animation frames, how do we promote layers, the JavaScript animation API, and some other stuff like that. If we get time, I'll show you some of the stuff that's coming up but maybe isn't well supported yet as well, such as the intersection observer. So what makes a good animation? First thing we want to think about is, what is our FPS target, right? What are we shooting for in terms of presenting something to the user? And this is harder than it may seem, but starting with the fundamentals, we typically want to be hitting 60 frames per second if possible, right? This is where something looks smooth. The user can't really tell that we're going across the page. So at 1,000 milliseconds, that means we have about 16.6 milliseconds per frame, right? That's how long we have to get each piece of work done. This frame math might seem a little strange now, but when we get into talking about animation frames, we actually want to make sure all the work we're doing is contained to that, or we're going to get even more chop than we started with before. The other thing to think about, though, is that 60 frames per second is not always achievable, right? We're dealing in a single-threaded environment here sometimes where everything else is clogging that main thread, or we just have too many elements that we're trying to animate. And in those cases, it's actually always best to have a consistent frame rate than having 60 sometimes dropping down to 30, going back up to 60, dropping down to 40. So if you can't consistently hit 60, which is a challenge in some environments, it might be better just to aim for a solid 30 or something like that. Because if the frame rate drops, a user can see, right, things actually slow down in front of them. And that's so much worse than having an animation that maybe looks a little bit slow, but is at least constant as they're going through the application. So there are two main ways that we can handle our animations. And again, as we go into examples, I'm going to keep tying it back to the stuff I'm telling you at the start. Our first choice is our declarative animations. These are ones that happen in CSS, right? So these are our keyframes or CSS animated those properties. Generally speaking, they're the most performant for a couple of reasons. As we get into talking about layers, they're typically going to be pushed to their own layer, and a lot of that work will happen on the GPU, kind of totally offset from the rest of the work our JavaScript is doing. And part of the reason they're so much more performant is that everything is spelled out up front. Right? So because everything's spelled out up front, we're kind of saved from ourselves. We're not having a bunch of sloppy work going on. The downside, which you'll see as we get into examples, is these can get really complex to write. Right? Your keyframe animations, unless you want to keep pushing new keyframe properties, which is a disaster in its own case, need to be predefined. You can't start from a position and define a start position on the fly, that has to be defined in your CSS at the time it's loaded. So that's why most of the time we're going to be using imperative animations, which are ones that happen in JavaScript, which tell the browser how. So these are much easier to write in code. They're easier to reason about. We can have dynamic starting and endpoints and a whole bunch of other stuff. But because it's happening in JavaScript, depending on how we structure it, at least some of the work is happening on our main thread. So now we have a whole bunch of timing problems that start to come as well. This is where Request Animation Frame or the Web Animations API, I'll tell you about both, can start to help you with that. There are still going to be some problems, and I'll show you all of those as well. So before we get into going to the examples, though, how do we profile an animation, right? We can look at it and see that it's getting cloggy, but how can we tell why it's getting cloggy, and how can we tell that we're hitting our FPS targets? Before we get into that, though, it would be good to stop and consider, well, how do things end up on the page? Because this actually is fundamentally important to writing something that goes smoothly. So if we think about, there's actually 4 steps. We're going to look at the first 2 and then go a bit further. How is content rendered on the page? So it loads your HTML doc, it loads in your assets, and what work is Chrome or Safari or Firefox actually doing? So the first thing it does is it goes and constructs a DOM tree, right? That's the thing if you pop over to your inspector, it's a little bit different internally, but just think of that as the same thing, right? It's a tree of all the nodes with parents and children and stuff like that. The next thing that happens is layout. And layout is happening from the top left of the page recursively down. And this is basically going through and figuring out, well, what goes where? And this is more complex than you might think because CSS is highly interdependent, right? One node that isn't a parent or a child might affect some other parent or child's positioning just because of what's going on. So layout is very expensive and highly interdependent. So these are some of the properties that actually affect our layout, right, when we're thinking of CSS. So obviously anything to do with width, min width, height, our paddings, displays, borders, font sizes, line heights, vertical alignment, right? Because you can see how these rules aren't contained just to the node we're looking at. It's going to start affecting everything around it. And this is where every time I'm here, I talk about reflow. So I don't know whether we know what reflow is yet, but reflow is basically the process of your browser needing to go through and recompute that layout. And layout isn't static, right? Once it's being done once, that cycle is going to have to keep going and going and going, depending on how badly we've programmed. So what causes reflow? One is changing any of these CSS properties on the fly is actually going to go and trigger a reflow in most cases. So changing the width of one node is actually going to cause a walk all the way up and down, sometimes more than once to figure out what's going on. That's still happening in your main thread, and this is when we start to see things clog up a little bit. So some other things that will trigger reflow, if you're interested, I put a link down the bottom there that will just give you a good introduction to the concept from a Chrome perspective. But obviously, any resizing of the browser window is also going to trigger a reflow. Changing any of those styles, JavaScript computed styles, and this one is going to become important as well. Adding or removing any element from the DOM is actually going to trigger a reflow. This will become important later as we get into animation examples, because sometimes you want to take something off the page that you're not using. But doing that is actually going to trigger a reflow, so sometimes it's better just to actually hide it away from the page until we're finished. So getting in next, once we've done our layout, we go into paint, right? So these are basically not our layout rules. These are ones that affect style to a degree, but they're not going to affect the nodes around them to the same degree. So our paint styles are things like our borders, backgrounds, background images, right? You can see how this is basically contained to the single node that we're using. And in a lot of cases, but not all cases, we can actually push a lot of layout work to the GPU, which is what we want to do as much as possible. It's basically a whole second machine that's sitting there that's not being used for most of our browser work or most of our rendering work. When it comes to paint styles, if you're not aware, opacity is actually a special case. It doesn't need to go and do all of the work again. We can basically just lower the alpha mask value up and down. Just a fun little thing to think about there. Then the last thing that happens is our layering. So the default is actually that all of those DOM nodes that you create are put on a single layer from the browser's perspective, right? They're all just janked up together. And what we want to do sometimes is we actually want to push a node that we know we're going to animate to a whole different layer. And what that means is as we're moving along the page, its math is completely interdependent from the rest of the stuff on the page. So layering becomes pretty important here, but the worst case is pushing each node to its own layer, right? Because layering is actually really, really expensive, and I'm going to get into what that looks like as well. The most performant option, though, from an animation perspective, and I'm going to show you examples of all of these, is that the hardware-accelerated functions, what we want to do is take those and animate, basically, or use those on a separate layer, right? So we're screaming across the page. We're not going to affect anything else. If you're not familiar with those hardware-accelerated functions, these are your translate X and Y properties and items like that. And these are considered special cases in dev because, typically speaking, they won't trigger a reflow. So it's a nice way to move something across the page without doing this really expensive act. If you're interested as well, so how do we make something go to its own layer? Using some of your GPU-accelerated functions will create an implicit layer on your behalf. This is why developers like them a lot. If there's something that you do want to push to its own layer, though, there's actually this will change property in CSS, if you've never seen it before. So what you can do is will change auto, which is the worst case, right? You're saying that anything could change. You can say that the transform is going to change or that scroll is going to change. And you're basically giving the browser a heads up that, hey, I want you to paint this as its own layer, even though that's not your default behavior, so that as we start moving across the page, we're saving ourselves some expensive acts. This is not the animation example. This was a precursor. But what you can hopefully see here is I've opened up the Chrome developer tools, and we're looking at layers. And you see this entire document, right? That ugly purple, yellow, red thing you can see is actually a template that I made for everybody here today. I don't have a career as a UI designer. I'm a programmer. But you see everything there is a single layer. So what I did is for those boxes, I went through and just said, will change transform, because I was just working on a precursor to the animation I'm showing you, where I was moving boxes left and right across the page. Then if you go through and see, you'll notice that each of those have basically now been pushed to their own layer. So we're in a spot where these are going to be a little bit easy to animate now. Don't follow this example as closely, though, because in this case, I probably shouldn't be promoting each single box, because I really could just put a container div and just promote that single layer or something like that. Last couple of things to be careful of before we get into examples is layout thrashing. So I actually put layout thrashing in the animations we're going to do together just to make the thread work harder. But if you've been writing JavaScript for a while, you should start to see a bit of a problem with this. Right, so what we're actually doing is every time we're running that interval, we're running a jQuery selector, which again has to go and do a whole bunch of work. We're dealing in a single threaded environment here, so we don't want to do that. So it's actually much better if boxes aren't going to change to go and pre-declare that, right? The less amount of work we can do, the better. You'd be surprised at how quickly our thread will start to clog up and all of our animations and timings will start to fall off. You know, half of animations is just keeping your JavaScript thread unbusy enough that it can actually do the work you're trying to do. So before we go to the animations, let's just quickly do a tour of the profiler tool so we can see how this works. If you've never used this, this one is in Chrome. And what you do is just, Control-Shift-J or Command-Shift-J or whatever it is. Go to your Performance tab, and it will open here. And you have the option to press Record. And just to take you on a quick tour, once you've pressed Record, this is what your profiler tool is going to show. So you'll notice in the top left, there's a screenshots option that I have selected there. And what that will do is it's going to continuously take screenshots of the page based on this timeline graph that you can see. You can't see my mouse, but based on that timeline. So you can actually go and see the state of your page at any moment in time. That highlighted box there is actually our FPS meter. It's showing, what was the average frame per second as we were going. So this is actually a really bad case, given it's only a single animation on the page, because the line is not straight or constant, right? So a user is going to be observing some FPS dips and some poor performance as we go. Right here is actually where you can see all of the screenshots that correspond to state. Another really good example of using this is on the first load of an application, and you're wanting to see how long is it taking for us to hydrate data into the page, and was that a good example? Instead of even trying to reload and observe, just run the profiler tool, and you can actually see the state as a page was being loaded in. And then the last thing is down the bottom here, we actually have our frame meter, and I'm going to keep using this with the animation examples just so we can kind of see what's going on. So our scene, I didn't get time to make it as fantastic as I wanted. I was actually going to vote them out. But this is our scene right here. If anybody recognizes this, if not, I don't care. I had to put it in there. This is Survivor. It's the best show on television still. So what I was originally going to do was vote out all of the animations. I just didn't get time. But what we're going to do is, if you can see the green bar to the left there, we're going to continuously animate things across this background image because it's slightly expensive to do that, especially as I keep adding in new bars. I was trying to come up with an animation example that would be very expensive without me needing to simulate a real web app and have a bunch of AJAX callbacks and other stuff like that in there as well. So let's go into our first animation, which is the absolute worst case. This is not how we want to do it. So hopefully that's big enough. I've tried to write code here that's easy to follow. I realize I shouldn't have a callback nested in a callback, for example, but for the purposes of demoing, this save my Mac function is not something you put in production. I'll tell you why, but I wrote these animations so bad that my Mac that lasts for 2.5 hours lasted about 20 minutes on the plane running these things. I was just chewing cycles nonstop. But what I do is, once the document's ready, I call a function called animateAbsolute, which I'll show you next. And then every 250 milliseconds, I'm injecting another green bar at the starting page. So we're going to have like this fan of things going across the page. And that animateAbsolute is just a set interval. And what I'm doing is I'm doing a layout thrash here, right? I'm doing exactly what I told you not to do, again, just to make it more expensive. And then basically for every single left box, what we're going to do is get the value of its left property and add 1 pixel to it every 10 milliseconds. Right? And that's how we're going to get the effect of them running across the page. So let's go and have a look at that animation. Can't see it on there, but right, this is already getting pretty choppy. And you notice how there, for some reason, we're not getting gaps in between all the bars in the way we'd expect. And at this point, we're basically ground to a halt, right? There's nothing in code making that happen. It's just stopped. Now it stopped because the video stopped, but you observe how it started to get chunkier and chunkier as time went on. So there's a couple of problems with that, but before I talk about why it didn't work, let's have a look at it in the profiler tool. So if we have a look here, couple of things. One is that we noticed that that FPS meter is actually dropping, right? We were trying to do a constant animation. Nothing was happening on the page, but it's going down, right? It's both wavy, but it's on a consistent cycle down, and that's not what we want to see in this case. So if we go in and have a look, right, we see that that's going down. And if we go and actually look at the frame meter, right, we're pretty consistently hitting maybe 50, 60 at the start, but it's dropping in a not good way. And as we get here, I can't see the video from here. You know, we're dropping down to 20, 30 frames per second. So something's definitely going wrong here. That's all you need to do to profile, right? If you can isolate the animation, just keep popping it in Profiler and see how it went. So a couple of our problems. We had that huge FPS dip that I showed you before. Part of the reason we have that FPS dip is because every single one of those animations is triggering a reflow. So we're just reflowing all over the case everywhere right now. We're not taking advantage of any of those hardware accelerated properties. I'm going to cover this next, but we're actually redrawing at a fixed but not fixed rate, which is important to consider, and that's why you saw those bars start to chunk up. And this animation is actually going to keep running in an unfocused tab, which is why my Mac was dying, right? A set interval is going to keep firing even if our tab is inactive. Sort of. So, two things there. One is that when a tab is inactive, your set interval is going to fire, roughly every second unless you have a higher interval time. So even though I said that I wanted that to run every 100 milliseconds, whatever I said, that is going to keep running every second even as a user, has unfocused the tab, is looking at something else. And that's going to start mucking up with all of our offsets. So we know that set interval is maybe not something we want to rely on as well. The other thing is that interval timing in JavaScript is actually not guaranteed. It's a best effort, and you should consider almost a minimum amount of time that it's going to take to run the next callback. So as our thread started to get busier and we were reflowing all over the case and the machine started to slow down, the reason you were seeing those bars start to clunk up is because the interval timing was off, but we were still animating at a constant 1 pixel as we went left, if that makes sense. So we both have a problem where our thread is clogging, but the way we wrote that is that if we wanted it to keep going in perpetuity, that problem is just going to keep popping up. Now, you may have noticed as well, before we go in and fix the animation, that I have those amazing fire animations in the back as well. So those I actually did not write myself. I took from SitePoint just to save myself some time. But that's where I'm using our CSS animations, right? So these are those ones I referenced earlier. This is what those look like. So you'll see I have a flame. I have the link down the bottom just if you want to see the rest of that site point. If you've never seen those CSS3 animations, it's a good introduction for you. But you'll see we have an animate property, which we've named Flicker, or dev named Flicker, I should say. And we've almost gone through and defined the different stages that are going on. So this is a really efficient way to handle an animation. But our problem with the example we're trying to do is that we can't basically tell the keyframes where they're starting and when they're ending. So as we're injecting new nodes, and we have a whole bunch of bars at different points in the page, this is really hard to handle, right? This is where we say that the CSS animations are harder to write. Because our only option really is to keep pushing new keyframe rules into the document, one for each bar, which is an even worse case than what we had. If you're curious, though, when we're doing the animation, some extra properties you can have there is you can have your duration, you can set a delay, you can also set the timing. So you can put all these properties in there. And this is really handy if you have a known starting point, a known ending point, and you don't have almost dynamic elements that we're adding into the page. So we didn't try it in this case because that's not what we're doing, right? We're adding new bars as we go. If you had a look at that, though, and you thought, well, that was kind of difficult, right? I don't want to define those rules in CSS. There's actually a new animation API in JavaScript as well. So what you can do is actually called .animate. And you can go and set the rules. You can put whatever you want in here. In this case, I'm just setting with GPU accelerated. And then you can set a duration, which is for how long each of those rules will run. In this case, it's going to run once every 1,000 milliseconds. I don't use this just because it's not supported on Safari yet. So this is something that's going to help us out when we need to start setting dynamic rules later, but it is maybe not ready today. It's just something to watch, unless you only care about supporting Chrome and Firefox, basically. So let's go in and try and fix this animation by running something that's hardware accelerated. So what we're going to do instead is we're going to run transforms, right? Something that we know we can punt a lot of work to the GPU. So in this case, transform translate x basically lets us move that node along the x-axis. You can do a whole bunch with transforms, right? You can translate y as well. So we're actually running the same piece of code here. We're running a set interval, which we know has problems. What we're going to try and do is just set the CSS to transform translate x and see if that fixes our animation here. Right, some of the chunkiness you see as well is my Mac trying to run Keynote and the animation and QuickTime to record at the same time. We're doing better than last time, right? It's not fantastic, but we're doing way better than last time. We seem to be constant, we seem to be animating, but now we're starting to see the same problem, right? So it took a whole lot longer for our thread to get clogged up because we punted a bunch of work off it, but inevitably we're in the same spot. We're starting to get a lot of clag, and we're starting to get those bars lining up. If we open that in the profiling tool, right, so we see our FPS is much more constant, but it very clearly starts to dip once we hit around 25, 30 milliseconds, something like that. And if we go and look at our frame meter, again, we have the same problem, right? We have a couple of dips that we don't want to see. Then we start getting some really big dips as time goes on, right? We've basically hit the limit. There's too much going on now, and even the hardware accelerated isn't going to save us. If you're curious as to what maybe one of our problems was, if you look down the bottom of that profiling tool, we can also see how much time is being spent on scripting right now. That's not good, and that's actually part of why we're clogging up. But if we go and consider the first profile to this profile, the net effect of those hardware-accelerated animations is scripting we actually have cut time off, right? So the first animation only ran for 20. We're now running all of them for 30. And even that given, we're spending about 1,000 milliseconds less time on scripting. We've gone from, on rendering, we've gone from roughly 10,000 milliseconds to 4,800. And for painting, we've actually increased the amount of painting load, which is fine because that's going to be happening somewhere else if we've done it right. So we've actually cut out a whole lot of work that was going on, but it wasn't enough. So if we go and evaluate what our problems were, FPS dip sort of fixed, sort of not, depending on what we care about doing. We're not reflowing anymore. We're still reflowing as I'm adding new bars to the page, but that's fine for now. We're taking advantage of the better properties. This is still going to keep running in an unfocused tab, though, and we're still redrawing at a fixed rate, which is how we're going to get rid of that problem of everything clunking together as we go. This is where animation frames come into play. They seem to be not used as much as I'd like to see. They're actually quite fantastic. They're supported for all major browsers. You don't have any compatibility problems using them. And an animation frame is basically, a function that's given to you knowing that you're going to be animating something quite consistently. It will actually only draw when the animation will be visible. So this saves our unfocused tab problem, right? An animation frame ain't going to be called if the tab is not focused when the browser is actually ready to do something for you. So this is going to save our other problem where we're running an interval every 100 milliseconds. And if it's not ready, it's just going to start basically having this huge callback queue build up. And when there are no other frames waiting to be drawn. So this is an optimization that's being created for you by browser vendors to handle this explicit problem. So it will go through, and it's actually going to eliminate a whole bunch of unnecessary draws and a whole bunch of unnecessary callbacks that we were seeing earlier. Just in case you were curious, this was taken yesterday. I doubt there's been a big ship since then. They're basically supported everywhere, right? So even if you're in a hybrid context, unless you're shipping to Opera Mini, which God help you if you are, you're going to be fine. So what does an animation frame look like? We're going to need to go through and start that init function a little bit differently now. You'll notice the first thing I'm doing is I just have a progress array to offset times. You'll see that on the next slide. Then I'm just calling window.requestAnimationFrame, and I'm passing it the animate function. Now, animate function looks a little bit different here, right? So I go through and I still pull the left boxes. We're iterating through the left boxes, but an animation frame is going to be called at a mostly but still somewhat inconsistent time. So we're going to keep using time offsets here. What we're doing is at the start, every time we add a bar, we're pushing to an array what is the current timestamp. And each time the animation frame runs, we're going through and getting the current timestamp and subtracting those two values to get an idea of how much time has elapsed. Once we've done that, we can go and compute a pixel value in terms of how much do we need to move. And this is also going to solve that problem of everything clumping together. So this is what an animation frame looks like if you've never seen it. The real trick here is that from within the call, we can go and call another animation frame, right? So we've had run one. We basically want this to run in perpetuity, for the example I'm giving you. And that's what's going to happen here. So to show you what this looks like, we still have some reflow problems adding the bar, but this is just running the animation frames. Start playing. There we go. So again, some of the chunkiness you see is just me not being able to record and do things at the same time. But you'll notice here we're not really having the offset problems. You'll see they're entering a little bit differently. That's because I was too lazy to get the math perfect. But we're not having the same problems we were having before anymore. This is in part because we're not clogging our thread, and this is in part because we're offsetting our math correctly, right? We're not every 10 milliseconds naively moving it 1 pixel to the left, even though that could have been called 10 milliseconds one time, 12 the next, 13 the next, 15 the next, then back to 10. So if we go and look at our profiling tool for this one, we see a few more lines than I'd like to see here, but we've almost hit something constant now. And if we go and look at our profile, right, it's pulled the values out because I know the screenshots are harder to see. From the last example, which was already better, we've gone from 5,000 milliseconds scripting all the way down to 2,600 milliseconds spent in scripting for the same amount of time. So we're doing a whole lot less work to get that out the door. In terms of rendering, we've increased a bit. That's fine because we've saved time elsewhere. And same with painting, right? This is also a function of I didn't get everything perfect at 30 seconds. Some went for 32, some went for 28. So if we go and look at our problems, we've solved most of them. But it still could be a little bit better, right? There are some problems with what was going on that page, right? We were still reflowing every single time we were adding an element. And also, every time an element went off the screen, I was never taking it out, right? So that's why all of these animations started to clag as we went on. Just because you can't see them doesn't mean it's not in the DOM, and it doesn't mean they're just not animating. It's just straight up out of your viewport. So sometimes the immediate reaction in those cases is, okay, let's go and remove the things that we're not using. That's a bad idea. Don't do it, because removing it is going to trigger yet another reflow. So what I did was I went and rewrote that animation again. Why don't I pull this open? I should have this open in Vim anyway. I use Vim. I just feel I need to point that out. So what we're doing here is we're going through. Again, I realize I could have kept this all in one loop. I have no idea why that's showing like it is. I guess we're going to look at it here for now. So what we're doing, a couple of things, right, is at the top you can see that I'm actually just going through and dynamically creating all the divs at the start. Then we're going through and, for each of the boxes, we're going to transform them. But you'll notice down the bottom of this animation frame, what we're actually doing here is, if the pixel value we're trying to move it to is greater than the width of the screen, then we're basically going to move that bar straight back, to the left offset again. And it's going to work like a carousel, right? Once it falls off this side, it's just going to circle around and keep going and going and going. So we don't need to add new bars as we're going anymore, and we don't need to remove any new bars. Excuse me as I change my display properties, though, so I can show you this live. Alrighty, we can see this now? Awesome. Right, so I probably should have added more bars in here, right, because we're just recycling the ones we use. But see here, we're just running way smoother now. So because we're not reflowing all over the place and we're able to recycle our elements, we're in a really good spot here. So that's the effect of going through and making sure that we've removed the rest of the reflows, but also that we're recycling elements. You might be wondering where this really affects you. The biggest case is actually in things like infinite scrolls, right? Where so often when something's out of the viewport, people feel a need to tear it down or tear it up, instead of just pump the item straight back to the start of the list, hydrate different data in there, and off we go again. And if you wanted to see what the profile of that last animation looks like, this is really what we've been trying to get to the whole time. Looks like we have a really constant line now in terms of our FPS meter. And if we go and look at the performance, we've dropped the scripting again, right? We're down to about 1,000 milliseconds scripting for that 30-second interval now. We've dropped the rendering down to about half again. And we've actually gone through and also managed to reduce the painting time in this case. Painting time's been reduced just because we've managed to get less objects on the page to do the same thing. So now that we've gone through that, we may as well spend the last couple of minutes just talking about some of the other ways we could have handled this. There's an intersection observer API, which has the same problem of not really being well supported on Safari or iOS Safari yet, which is a deal breaker for the type of work I do. What the intersection observer API lets you do, I just took the description from Mozilla here, is it basically lets us define a target element and see if any other elements have hit or intersected that yet. So as you're working on something a bit more complex, it becomes really easy to go through, write your intersection observer. Your threshold there basically is how much of the elements need to be overlapping to trigger this callback. So you might set that to 1, which means a complete overlap, .5, it's calculated off the surface area. The root will default be the body. That's usually not what you want, but you might want to define some element that is your listener, right? When any other element is 50% overlapping it, you want your callback to fire. And the root margin just lets you extend the margin of that single object as you're going if you want it to be a bit bigger for the purpose of overlaying. So you have some choices there. And what will happen is that callback will run and basically pass to you any element that's triggered that. So, maybe in a later day, instead of having a naive width implementation, we would have just had bars at the side of the page, and when one of the green bars hit that, the intersection observer would have fired, and we would have changed the left property from there. Last thing I'll cover as well is just passive event listeners. If you've never used them, again, this is something that will help you cut down on the scripting component of that profiling tool so that we can start going a bit smoother. What this lets you do is indicate that we're not going to call prevent default in any context. So it's just less work that's going on your behalf. It's really simple. All you need to do for your listeners is pass passive true. This is something that I almost always use on touch and scroll callbacks unless I intend on using the behavior as an example. You'd be surprised at how much time you're able to save doing it that way. So just to wrap up, in terms of my best practices for trying to get something like this done, the first thing I'll usually do, right, is if I'm trying to write an animation that's tight, I'm going to pull that out of the actual web app to start with until I can get it working well. Then we'll put it back into the web app and see how it's going, once we're dealing with AJAX callbacks and a whole bunch of other things. I'm avoiding the JavaScript animation API just because I can't afford to not ship for Safari. Especially I build hybrid apps, that's mobile Safari. I can't do it that way. The pages with the smaller animations, the CSS hardware animations are fine. If I can stick within those keyframes, right, those CSS3 animations, I'm going to do that. In most cases, I can't, though, right, because I need to calculate offset, start positions, and things like that, which is where I'll either just write a custom translate animation, and I'll typically always use animation frames for that, because no matter what else is going on, I can trust that my offsets will be correct at all moments. So thank you very much. That's the end of just talking about how we can start with an animation that's really not great, look at what's going on, and try and build something a bit more performant out of it. I'm out of presenter mode now, but I think it's still running in the background. Perfect. We still have some time or a couple minutes for questions, if anybody has any. Thank you very much.